for the product rule. So just remember that when we're taking the derivative of two functions together that are multiplying, we do one function at a time. So we take the derivative of the f function, leaving g alone, and then we do the derivative of the g function, leaving f alone, and then you add the two together. And so that was the product rule. And so now let's do a few examples, just so that we get it down cold. So here's some practice problems. So if you're feeling comfortable with it, go ahead and make an attempt at them. Hit pause then, and then once you got it down and you want to check answers or check the approach, then start it back up again. For the first one here, so we're doing the derivative. We have two things multiplying, so that's why we're using the product rule. And the product rule is basically saying take the derivative of the first item, so that's why we're getting a 21x to the 6 minus 12. We're only doing the first. We're leaving the second one alone. And then we do the derivative of the second piece. That's where you're seeing that 10x to the 4th, but we're leaving the 3x to the 7th minus 12x. We're leaving that alone. We're not touching that. We're doing the derivative of only one piece at a time. That's the key thing for this product rule. And then if basically we've done the derivative, that's the derivative. A next step that you may have some of your professors ask you to do is to kind of simplify this expression, start doing some algebra to combine things together. So just remember that that 21x to the 6 gets multiplied through, and then the negative 12 gets multiplied through. And then on the other part of the term here, we got that 10x to the 4th goes through as well. So basically we're doing some multiplication going through, and this would be the result of those multiplications, of those 6 multiplications that we have. We have 6 terms here, and we're noticing, hey, some of these terms have the same power. They're like terms, so you can combine your like terms together, and there's your final answer. So there's your final answer for the derivative of that expression using the product rule. For the next problem, we basically are doing the same thing here again. We have two expressions or two things multiplying together, and we're going to do the derivative. We call one f, we call one g, that kind of idea. But the key idea here is we're just doing the derivative of one piece at a time. So I'm taking the derivative of that x to the 4th minus 5x to the 3rd minus 12. We're doing its derivative. You see it in blue there. But the x to the 3rd plus 37, that's the g function. We don't touch the g function. It comes along for the ride. Then for the second part there, we're going to add on the first function. The f function is going to come along for the ride. No change here. And then our next part is, what's the derivative of x to the 3rd plus 37? It's 3x squared. So there is the product rule. That's the derivative. The next steps that we're playing with is just the algebra to clean it up. That's all we're doing now in the next steps is algebra. So once again, we're multiplying the 4x to the 3rd through. We're multiplying the 15x squared through. And then we're going to multiply that 3x squared through all the way through. There we go. And so we're going to be doing that multiplication, those 7 multiplications. And when you do those 7 multiplications, this is the expression you get. And so our next step would just be combine like terms. So I'm looking at an x to the 6th terms. I'm looking at x to the 5th terms. I'm looking at x squared terms we can combine together. We'll have a leftover x to the 3rd term, but that's what we have. So just combining like terms. And that's our final answer. So what you're seeing here is the product rule, the actual derivatives, is a very easy, straightforward first step. Where I see my students messing up, it's usually in the algebra. Okay, and so our next example here, this one's slightly different. I've got an extra step here because I'm seeing that square root. And so for me to do that square root, first thing I want to do is rewrite that square root with that power 3 there that we're seeing here in this term here. Basically, we've got a square root, which is a half power, but because that power 3, we really technically have a 3/2 power. And so I wrote it as 1.5 to be consistent with the other 2 powers that we have that are decimals. Okay, so now that I've rewritten the power of that one term, it's now basically product rule because I have 2 things multiplying. And so I'm taking the derivative of the first thing, bring that 2.3 down in front, and then the second, the g function, it's coming along for the ride, not touching the g function. Then the f function comes along for the ride, and then we do the derivative of the g function, of the second function. And so that's what we've got. There's your derivative using the product rule. That's the derivative step. The next stage on is just doing algebra. Once again, just multiplying those things through. That 2.3x to the 1.3, you're just going to multiply that through to get 3 new terms. And then we're going to go on the second part and do some multiplication there. And so we're going to multiply there. I've lost an arrow, so there was supposed to be another arrow there from the 1.5 all the way to this 91. So basically what we're having here is we're having this expansion of this. We get 3 terms from the first part multiplication. We're going to get 4 from the second one, which we do. And then noticing some like terms, put the oh, there's my arrow, and then put the like terms together. And so that's what we have for our final answer of the product rule. Okay, and so we've got one more example to do. Hopefully this is making sense in here. But the catch is, the derivative part's very straightforward. It's the nice do one derivative at a time kind of thing. And it's the algebra afterwards that usually people don't like. Okay, so now on this one, our final example here for the product rule, what I'm looking at is this other notation right here, this vertical bar with x equals 3. Basically what we have here is we have a two-step process. We have to do the derivative on the expression. When we do the derivative, then we're going to evaluate at 3. So we're going to plug 3 in for our x's, but that's after we do the derivative. Don't plug in before doing the derivative, plug in after. Okay, so two things multiplying, so I'm going to do the product rule. So I'm going to do the derivative of the first piece, and then I'll do the derivative of the second piece with the other two things coming along for the ride. And I still got my vertical bar x equals 3 just to remind me. My next step, still got to plug 3. Now, recommendation here. If you're not really liking your algebra, you can save some hassles, I guess you can say, is that instead of doing algebra to clean this thing up, combine like terms, you know what I'm going to do? Because it's evaluating x equals 3, let's plug 3 in. Why do all that extra algebra unless you really don't have anything to do this Friday night? But if you do, go ahead and plug the 3 in. Make it easy for yourself. Plug those numbers into the calculator, crunch it out, and get an answer something like 14 million. Okay, so basically if you're evaluating functions, it's really nice. You can do the product rule. You don't have to simplify. You can plug your numbers in. You can evaluate it. And you're done. Who needs to do all that algebra? Okay, hey, this is Dr. Pat. You guys have a good evening, and we'll catch you on part 3 when we start looking at the quotient rule.